In this unit, we're going to talk about arrays of strings. We learned that a string is a character array. So an array of strings is, you can think of it in a way like a 2D array of characters, right? And if you want to equate then strings into words and characters, right, or a sentence, we can break a sentence down into different words. In this example, we see then the quick brown fox jumped over the lazy dog. The sentence is composed of several words. And so if you think of each one of these as an individual string, or if you think of this as an array of words, right? There's 1, 2, 3, 4, 5, 6, 7, 8 words. We could say sentence, make an array out of the words, where if we created some array named sentence, right, we'd see that we had to leave room for 8 words. But then each one of those words needs space for the amount of characters associated with that. So we then could say the sentence, right, is made up of words. The words are made up of characters. And that gives us a 2-dimensional array where we have to allocate space for the number of words in our sentence, and then we allocate space for the number of characters in each word, right? And then the data type is char. So here's an example here. If I then create a 2D array called message, MSG, so this tells me too how many strings or how many words I have in it. We'll have 2 strings or 2 words. And then I'm allocating 10 characters individually for each one of those words. So, and then I'm initializing it here. Message at index 0 would contain the string hello. Message at index 1 would contain the string world, where I'm leaving room for 10 characters, but hello is only taking up 5. World is only taking up 5 in its particular string. And then I can refer to each one of these using the 2D array notation. So message at word 1, so message at word 0, so there's word 0, hello. Character 0 is the character hello. Message at word number 1, right, is word number 1 I refer to as world. At position 0, so character 0 is W. So let's just take a look at the idea of what we really have here are arrays of pointers, right? We've been studying pointers. Let's just take a look at the whole idea of arrays of pointers. So actually, just let's let's just open up the old main example and erase what was there. Actually, here, what we're going to do is we're just going to create an array of pointers. So here, let's declare an array of pointers, right? And what we're going to do, let's declare an array of pointers to integers. Let's forget about characters for a moment and let's look at some integers. Oh, if it's a 2D, so an array of pointers. So I know then a pointer to an int, my data type is int. I have to then use this notation to make it a pointer. So if I say PTR, that's a single pointer. An array of pointers, well, I have to say how many pointers do I want? Well, maybe here if I say I want 4 pointers, right? So this is an array of 4 pointers to ints, right? And it's like I have declared then, right, PTR 0 is one of my pointers, PTR 1 is another pointer, PTR 2, and then PTR 3. Right. Now, in order to use a pointer, I need to have it point to something, right? So let's just then declare some other variables. So I'm going to say int, let's make x, let's go ahead and make x equal to 9, y equal to -3, z equal to 77, and let's make one called r. Let's make that equal to 36, right? I'm just picking random values here, right? And now I could say, well, let me take 4. So I could say PTR 0, right? I can assign to that the address of x, right? So PTR 0 is assigned the address of X. It points to X. Let's just go ahead and print out. So let's print out address of X is, let's say, %P for that, right? And address of X. And value stored in PTR 0 is %P. Right, it's going to be an address, or we can use %U for these as well, or %X for the hexadecimal numbers. All right, I'm just going to say PTR 0 here. All right, and let's maybe make these line up on the screen. All right. Oh, sorry, I didn't include this. Oh, I'm going to start with a different example. Let's remove this. Let's add this to our active project. Now let's build and run. All right, so we can see that the address of X is 0028FEF0, and the value stored in pointer 0, because we said store the address of X in pointer 0 is this. So if I were to just use pointer 0, as we did here in the printf, that refers to the address of X. If I want to now get inside, if I want to read the data where pointer 0 points, I could simply say, right, the reference PTR 0 returns the value. That's going to be an integer. I need to use the indirection operator with PTR 0 here. And let's build and run. It's going to be an alias for X. Right? So we see then PTR 0 points to X, but when we use the indirection operator with PTR 0, it returns 9, which is the value stored in X. So the indirection operator with PTR 0 is simply returns the value where this points. What I did here, instead of making one pointer, right, is I made several. We're used to notation something like this, right, where we make one pointer. Well, now when I make an array of pointers, I now made an array of 4 pointers. They can all point to integer data types. Here then, I went ahead and assigned pointer at index 0 to point to X. Well, I could similarly now assign pointer at index 1. Maybe I want to make it point to the address of Y. Pointer at index 2. Right, I can make that point to the address of Z. Pointer at index 3, then the address of R. Right? And if I use the loop to walk through this, so for int I equals 0, I less than 4, let's go ahead and say then let's get rid of this. All right, we're going to print out what's stored in PTR at index I. So I'm going to use %d there, and let's substitute in the value of I. All right, and here this is going to be the value of I. This will be the value of I. All right, and so then we're going to show then the address. So we'll show the value of I. So pointer to index will show that what's stored in that pointer, which will be the address of the X, Y, Z, and R as we go through. And then we'll show that use the indirection operator to show what's stored in those variables. So run the cursor. All right, so see I have this array of pointers, and they've all been assigned different addresses here. All right, now, as we go into the for loop and execute, I set equals to 0, 0 is less than 4. So we're just going to go ahead and print out then this address, right, pointer 0, we should see the FEF8 printout, and then it points to X, and we should see the 9 printout, just like we did before. So if we pop this up, notice then, right, we get this address, and then we use the indirection operator to return the value where this points. And here then, if we continue to step through, right, I becomes 1. Well, we'll see that this is now pointing to the address F4. It's going to then display what's stored in Y's value, which is -3. Right. And similarly, if we continue to walk through here, we'll just print out this other information. Right, so what we did was we created an array of pointers to ints. We made them point to different individual variables. Right. Now, it doesn't make sense as much in the case of individual variables. What it makes more sense is in the case of maybe I want to go ahead and make an array of pointers point to another array. So let's take a look at an example like that. Stop the debugger here. All right, now let's go ahead and create then some different arrays. So again, array of integers. So here's array 1, right? I'm going to use the blank notation here, and I'm going to say, I want you to initialize this with 1, 2, 3, 4, and 5. All right, so the size of this should be 5 elements, and array 2. All right, if I initialize it, maybe with even numbers, 0, 2, 4, 6, 8. This will also have 5 elements in it. In array 3. Then, let's make that the odd numbers, 1, 3, 5, 7, and 9. Right, and that has 5 elements in it as well. Right, remember the size of these, since I don't specify size here, is determined by the initializer list. Right, and so what we did was we declare and initialize 3 integer arrays that all contain 5 elements. Right? They're all of size 5. And now I'm going to declare an array of pointers and initialize. Them. All right. So now I'm going to make an array of pointers to ints. So remember, whenever I want to make a pointer, it's going to point to an int. I'm going to call that PTR. So that's just a plain old pointer. If I want an array of 3 of them, I now have 3. And I can say, now I want to initialize you. Pointer at index 0 is going to point to array 1. Pointer at index 1 is going to point to array 2. Pointer at index 2 is going to point to array 3. And now let's see what happens if we have I equals 0, I less than 3. We're going to, let's see what happens when we walk through here. So what if I just go ahead and say printf, let's print out i's value, %d, and let's now print out, then let's use the indirection operator with ptr at index, the index, and we'll show what that value is, which should be a decimal, right? And now I need to substitute in I for this first one, I for the second, and then the indirection operator with ptr at index I. Let's look at our output. All right. So as I goes from 0 to 2, we see when I0, if we use the indirection operator with pointer at index 0, it points to the start of this array, right? Because what we did is we said we want pointer at index 0 to point to ARR1. Well, ARR1, when we use it, just gives us back the first integer in the array. All right, similarly, pointer at index 1, when we use the indirection operator with that, well, the first element here is 0, and so it returns the 0. Right, so when we use the names of these pointers, when we initialize this and we use them, it's the same thing, basically saying, as go ahead and assign this to the address of array 1 at index 0, array 2 at index 0, array 3 at index 0. When we use the indirection operator, then, with each one of these, we point to the start of each one of these arrays. So this first one comes from here, the second 0 comes from here, the second one comes from there. You can see then all I did was access the start of this array by doing this. Right. If I wanted to access then more than that, I would have to use some other sort of pointer math or notation. But the idea here is just to introduce you to an array of pointers. Right. In this case, we use them with ints in sort of a non-intuitive way because the point, no pun intended with pointers, the purpose was to show you that with this array of pointers, when you set them equal to then the start of this array, and if you use the indirection operator like we did here, you're only going to get the first array element, right? You're pointing to the start of the array. Right, we want to take that idea and transition that over to characters and strings to take a look at that data. So let's then, what happens if I make these all chars? All right, and now instead of integers in here, let me just go ahead and initialize this. Let's use the string initializer so I don't have to use the list. Hello, right. We'll just make this ELEC. And let's make this 1520, the name of our class. Right, so each one of these arrays, this one is 5 characters long, actually 6 plus the null terminator, right? ELEC null plus null terminator, 1520 plus null terminator. Right, now I need to then make this a char. In this, so three character arrays. Right, they don't all necessarily contain 5 elements. All right, so we've initialized these. Now I make this point to the start of each one of these. Right, so what happens if I loop through this now? What happens if I say, as I loop through this, I still want you to show me the value of I, but now when you access what's in memory, what happens if I say treat that as a string? So we're still looping through, right? We're going to now treat this as a string. So let's, sorry, I still have this old example running. Let's go ahead and build, right? No warnings, no errors. Let's run. And I killed memory. It's not very happy with me at this point, right? So what did I do wrong here? Was it because I wanted to treat these as a string? What happens if I said treat this as a character? So it works if I treat it as a character, but crashes when I treat it as a string. In a similar way, right, before with integers, when we initialize it with that long list, when we use this, we got the first element in the list and that worked for us, that first integer. Well, here I can only get out the first character. It really doesn't like me trying to treat that area of memory as a string. All right, so here it's letting me get the first character. There's the H, the E, and the 1 there. All right. Let's take a look at another way we can do this. So the thing we saw, right, is this crashed with us trying to treat this as a string. Even though, in this case, this pointed to this, right, when I tried to say, go ahead and return pointer at that particular index, right, it didn't want to give me the whole string. Right? When I build, I get no warnings. Actually, let's clean the workspace. Let's compile. No warnings with compilation, with my warning levels, but we get that crash. We said, well, let's treat this now as, don't try to access all of the memory, just the first character. Right. That worked. We got that first character. Now, instead of initializing these like this, let's try something completely different then. Let's get rid of this. Here in my initializer list, let's give this 3 strings. Same 3 strings. Hello, ELAC, and 1520. 3 same strings of characters. All right, I just kind of cut out the step where we initialize all these to pointers, so build and run. All right, we get the same 3 first characters. Now, can I treat this as a string here? Can I do this? We're going to crash again. We are going to crash again. All right, now, but here, if I don't use the indirection operator, if I just say, give me what's at PTR at index I get the whole string. So here, right, PTR at index 0 is a pointer to this entire string. So I can use that then as to reference the string. And PTR 1 is this string, ELAC, and PTR 2 is the string 1520. If I were to put the indirection operator, so that tells me this returns a char star data type. This returns a character data type. This says go into the individual string then and return them. Right? Return that character. Treating it as a string, it doesn't like that. Treating it as a character, it's happier about that. Right. So there's a lot of nuances with pointers. There's a lot to get used to when you're working with them. You have to start thinking in terms of the data type it might return for you. Using the debugger can often help you find out what's going on. Here, if we wanted to walk through the individual characters now, we could start treating these as more of a 2D array. So here, what happens if I were to say for int j equals 0, and then I want to then say PTR at ij not equal to the null terminator. Can I use this 2D array notation when I only made this a 1D array? And plus plus j. Now here, can I do this? Can I say, right, let's print out I. Let's print out j so we see it. And now let's use the notation of, choose this notation. And so now I have I, j, ij. I don't want the indirection operator. I want j. I'm missing a curly bracket there. left-hand operand has no effect. Here we go, semicolon. All right. Oh, let me do one more thing. Every time we get done with a word, let's just go ahead and let's do a couple of blank. Let's put a blank line in between everything. All right. So look, I made an array of pointers. Each one of those pointers, so if I say pointer to index 0, I'm referring to this entire string. But when I say index 0, then character 0, so word 0, character 0, I get the H. Character 1, I get the E. Right? So here you can see my I and J. So I is my word number, my string. I refers to the entire string. Then the J within here refers to the character. Notice because I'm dealing with strings and these were different lengths, I'm checking to see we want to keep this looping until we get to that null terminating character, at which point we want to go back up and go to the next string or the next word. Right? So you can see this is a way that you can access each one of these individual characters within a string. In this case, we made an array of pointers to chars. We initialized them with these different strings. Is that these take a lot of time working with them to get used to how all of this works. And of course, it takes consistent time working with them on a regular basis, not a one-time. When you haven't used it in a while, you have to come back often and review. But we use pointers then. The idea of arrays of pointers will come through it, especially in our next topic, command line. But we'll use that with strings. Right, so let's go back then here. Right, this is what we were getting at here when we talked about 2D arrays. Right, how we can have a 2D array of characters. In this case, what we're going to do with example 7 is we're going to do something very similar. We're going to look at this written as a 2D array. Right, let's pop that up. So here we simply made an array of pointers, but they were an array of pointers to char. So when we then reference the pointer, the index location, we reference the entire string. Right, we need the second then attribute here to reference the individual characters. Let's go ahead and open example 7. Shut that. Let's add this to our project. And let's remove main. All right, now let's take a look at this. So now, instead of making an array of pointers, I just flat out made a 2D array of chars. Right? Where now, think of this as 4 words. So there's 4 words. Each word can contain up to 20 characters. Right? And so here's our first word. So this is sentence 1 at index 0, sentence 1 at index 1, index 2, index 3. Right, so if I want to go through here, then I'm calling these control variables word. When word equals 0, as long as word is less than 4, then I want you to go through inside now in another nested loop. I'm going to set character equal to 0. As long as sentence at word character is not equal to null terminator, increment character. And so what we're doing is we're going to loop through these, then literally character by character. Right? Let's build and run this one so we can see the output. And sorry, my bad. I looked at the wrong example. We are going to go to this example 8. So as long as we're here, let's look at this 2D array. I just need to add it file to the extra project, and then we'll go back and look at example 7. All right, so this example 8 is one we just looked at. All right, so what happens is here, we used a nested for loop to go ahead, and we're printing one word on a line, right? So this loop is then saying, go through here, print out each character. So I don't have the curly brackets, so this is the one statement associated with a for loop. When this for loop finishes execution, it prints the new line character. So when it loops back up here and starts on the next word, we get the next word on its own line. right? Remember then, because we're doing this character by character, we have to end this inner loop when we find the null terminator, simply because we have allocated 20 characters, but not all of these take up 20 characters. So we use the null terminator to know when we're at the end of that string. All right, so that's a way to do it with a nested for loop. What example 7 was showing you was to do it with a single array or one-dimensional array. Let's open this up. All right, so example 7, one-dimensional. So here we still have, right, 4 words, 20 characters for each word. We still initialize them to this as a sentence, but now we have the single loop. And in the single loop, when I just refer to this as sentence 1, so sentence 1 is the name of the array. When we refer to this as with just a single index, that refers to the entire string. So if we use %s for this, we get the entire string. All right, let's add this to our project. Let's remove example 8 from the project. All right, and so build and run. We get the same behavior that we did from example 8, but now we use the %s and just use this to refer to the entire string. Right? If I made this a %c, here, let's see if I'm going to get and build and run, we get nonsense because this is referring to a string, and we get some sort of nonsense here, which is related to the fact that when we refer to this, this is actually an address, and if we don't use the %s and pull this out in a character, it's trying to equate that address. So we get nonsense. All right, so this needs to be %s. So in other words, right, when you declare a 2D array of characters and you just use then this first index to refer to it, it refers to the entire string. When you then use both indices to refer to this, right, if we open up example 8 again, here, where then in this case we use the nested loops and then we use both indices to access then the character within the word. All right, so 2D array probably makes a little more sense to you than an array of pointers, right? It's a little more confusing than with strings, right? When we just use the one index here, we refer to that entire string. We can reference the whole string. When we use both of these indices, then we refer to the character within that particular word or that particular string. All right, so let's look at one more example of how we can use an array of strings. And so let's close these down, close this down, and we'll remove this. We're going to write another program. I'm just going to open up main again, probably quickly use that. Oh, and all right, so we're going to write a program that uses an array of characters to display the name of the day corresponding to a number. All right. So display the name of the weekday corresponding to the number of the weekday. All right, so here's what we're going to do. What we're going to do in main is we're going to prompt the user. We're going to then create a variable, let's call it day number, right? And we're going to ask the user to enter that. We're going to say something like printf. Enter the day from 1 to 7. Right. And we'll read that in with scanf. That's an integer, so we'll use %d, right? And we'll give it the address of day number. And now we're just going to assume that the user correctly enters something in the range. We won't do any error checking here. And then what we'll do is just let's take a look at this, right? At this much of the program. We'll see then. Right, if we build and run, we'll get the user to enter some information. And I didn't add that to the active project, so we won't get anything. All right, now if we build and run. Right, end of the day, right, whatever I type in is going to be stored in that variable and our program ends. So what we want to do is we want to take this number and we want to relate it to Saturday, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday. So let's go ahead and create a function called day of week. We're going to create this function called day of week or weekday, and we're going to pass to that some integer, right? We'll just call it number. That's one parameter this is going to get. And so what this is going to do is in here, we're just going to create then some sort of character array. So char star weekday, and there's 7 weekdays. And each one of these is of a different length. So I'll just initialize this, right, with, I'm going to start with, Sunday, right, Monday. So Sunday is going to be day 1. Right. Tuesday, Wednesday, Thursday, Friday. All right. There's my initialized array weekday that will exist every time we come into this function. And what I want to do is in here, I want to then see, I'm going to check to make sure we're returning some valid day of the week. So I'm going to say if, if number is greater than or equal to 1, or number is less than or equal to 7, that's within my range, then I simply want to return, weekday at index location, whatever number is. Else, I'm going to return the null pointer simply because I'm out of bounds, right, of my array. Now, I don't have a return data type for this. My return data type is going to be a char star because I want to return a string, a pointer string. So if I make this a char star, right, what I want to do then is back here in main, I need to use some code then to access this, right? Back down here, we've got our day number. What we want to do is we want to say, let's create then something, a char star. I'm going to call it day here. And I'm going to say, I want to assign to day. And I'm going to call the function weekday. And I'm going to pass it then here, day number is what the user entered. And now I'll just say, if day, right, or if day not equal to null. Right, now I can say, let's go ahead and print out the day. Else, well, maybe we'll just print out, right? Or this would be a good place to maybe use puts, right? Invalid day. Some sort of message. All right, implicit declaration of function weekday. Well, yeah, I called it day of week, so if I don't call it by the same name, that's not going to work. Right, build and run. Right, so if we give it a 1, we get Monday, right? Because Monday is at index 1. What happens if I give it a 0? So do I really want 1 through 7 or do I want 0? Because here's my problem, right? Here, if number is greater than or equal to 1, do I really want weekday at number or do I want weekday at number minus 1? Let's take a look at that logic. Right? Since my first index happens to be 0, but yet I have the person typing in a number 1 through 7. I need to adjust that, right? Because we thought 1 should be a Sunday. Build and run. We said we wanted 1 to be Sunday, right? Which is at index 0. And if we run again, right, 2 is going to give us Monday. So if we keep testing, this will work. Let's run it with an out of bounds range. 8 is out of bounds. And why did I get... where did I get that for 8? Run to cursor. Time to use the debugger. I got 8. All right, so here I'm in number equals 8. Oh, the OR was not the condition to use, was it? All right, it must be time for me to take a break. This needs to be AND, not OR, because the OR made this true, right? Short circuit evaluation, as soon as this was true, it returned that information, which didn't even exist. That test needed to be an AND. Build and run. Now if I put in the 8, we get our invalid day. All right, so there's an example where we can use a character array. We can return a char star because we're returning a string, right? The string is a char star. That's what we're returning back here, right? We had to capture that with a char star back here. So here's another example then of sort of a 2D character array. Right, that's the end of this section on character arrays. The last section of chapter 13 in King is over the command line. That will be covered in the next lecture.